me and everyone to give something back to the community. And with this talk, I hope to help some of you to learn something new about AWS. If anything that I'm presenting it's not clear or you want to learn more about, feel free to reach out. I'm here today and tomorrow, or you can get in touch on LinkedIn. I really want to give this back to the community, so if you don't understand something, please reach out and allow me to help. Now, my name is Eduard Agavriloae. I'm an associate manager at KPMG Romania. My areas of expertise are cloud security and web exploitation. I write articles on securitycafe.ro. I'm doing also research on cloud security. I also have a cat that also likes DefCamp. This is her 2 years ago. Now, I don't think she will fit anymore in this hat, but that's the way it is. With this talk, I hope to show you what types of privilege escalations are in AWS to help you identify attack paths and help you in executing them. It's not necessarily an introductive talk in AWS, but we'll try to cover the basics as well. Now, let's talk about what is privilege escalation in AWS. And let's take the next scenario. So anytime you see that we have this red skull, that is our level of permissions as hackers. So that is the compromised identity. And let's say there are two user accounts, one Alice that we compromised and one Bob. And they are part of the same AWS group. So they have the same level of permissions, they have nothing different. In this case, if we move from Alice to Bob, we will say that we did lateral movement, so it's not privilege escalation. Now, let's say that Bob has one additional policy. He can list a bucket. Even if it's only one policy, if we move from Alice to Bob, we can say that we did a privilege escalation. Now, obviously, the impact is not so great, but in theory, is still a privilege escalation in AWS. Now, let's take another example. Let's say that we have a bucket with a policy that is denying access to Alice on the bucket. So both of them, they normally can do things on every bucket, but since this bucket has a deny statement, Alice will not be able to do anything on this bucket. Again, if we move from Alice to Bob, we can say again that we did some privilege escalation. And one last example, let's say that there is a role in this AWS account that only Bob can assume. Again, if we move to the user Bob, we can say that we did privilege escalation because we can access the permissions that are on this role. Now, some types of privilege escalations, as a disclaimer, this is not something official. This is something I categorized based on my experience. So maybe you'll find different opinions out there. But for the sake of this talk, if we are working in the same AWS account, there are multiple types of privilege escalations that we can do. And one of them is YAM Privesc, which stands for Identity and Access Management. So basically, you have access to some permissions that are allowing you to further extend your permissions, like assume another role or attach another policy to you. And then we have service exploitation, where you are either creating, modifying, or hacking services that already have permissions in order to gain access to more permissions or access other resources through these services. And then we have ABAC Privesc, which is attribute-based access control in AWS. It's kind of like role-based access control, but we'll talk more about it later. And now, if we are looking on multiple AWS accounts, we have this cross-account Privesc, where from one AWS account, you can access external AWS accounts, and we'll talk about what it would mean to compromise or gain access to a management account in one AWS organizations later on. Now, who is familiar with this diagram? Okay, so this diagram will not get into much detail about it. This is the policy evaluation logic when AWS tries to determine if you can do something in AWS. And if you are doing Privesc, if it's working, this is not relevant. But if it's not working, it might help you to take a look around here to see at what point you have a deny statement that might prevent you from completing the attack vector. Now, let's start with the classic privilege escalations that are based on YAM. So there are 28 well-documented Privesc vectors about YAM. They are documented by Rhino Security Labs. They have an amazing repository where you can find these Privescs, scripts for exploiting them, and scripts for identifying these issues. I think it is the best resource out there if you're just starting with Privesc on AWS, so I highly recommend it. Every vector, basically, it either modifies your permissions, modify resources to steal permissions, or creating new resources to steal the permissions from these resources. Basically, that's how these YAM vectors are working. And let's see some examples. Now, in AWS, the permissions are in this form. So we have the service followed by the action. And in this case, the service is YAM, which stands for Identity and Access Management, and the permission is to attach user policy. And these permissions are pretty much self-explanatory. And let's see some examples. So we have a compromised user that has this permission to attach user policy on any resource. And now from the CLI, we can attach the administrator access permissions, which is a policy that grants the highest level of access that a normal user in AWS can have. And once we are doing that, the policy is attached to our user, and basically we have administrator access permissions in this AWS account. So it can be very easy, just one CLI command. You just need to have the right permission, and you will gain full access in the account. Let's see another example. So we have create access keys, which will create access keys for another user. And this is Bob. We didn't compromise Bob yet, but he is an administrator, and we want to compromise him. And we have this permission to create access keys, and we will do that. So we will create a set of access keys for Bob. And once we configure the access keys, we will then have basically the identity of Bob. So here we create the access keys. Here we configure its credentials. And then with get caller identity and profile Bob, we will be the user Bob. This will not work if Bob already has 2 sets of access keys, because that's the limit in AWS. But usually users have only 1 set of keys, or they don't have any. Another example is put group policy that will allow you to add a policy to a group. So let's say we compromised a user that is part of this group, devs. The permissions on this group are not relevant, but we have this permission, put group policy, and here we have the permission. Sorry about that. So we have this policy that basically allows any action over any resource. And then we just put this policy on the group devs. And after we are doing that, the policy will be on the group, and since we are inside that group, we will benefit from the permissions attached to the group. And the last example, we have update assume role policy. So the roles in AWS, they can be assumed by anyone. You have to specify who can assume that role, and even if you specify someone, that user also needs to have the permission to assume the role. And let's say we compromise the user that can modify the assume role policy overall, and this role has administrator permissions, but it can only be assumed by the user Bob. And we have an additional condition here. Bob must have MFA enabled in order to assume it. So that looks good, but because we have that permission to add another policy, we can do something better than just allowing Alice to assume the role. We can backdoor this role. So this is a different AWS account, and this root doesn't refer to the root user. It refers to any identity in that AWS account. So basically, we are saying here that besides Bob, any user from this AWS account, which will be our AWS account, we as hackers, will be able to assume the role. And we can leave the MFA condition here because in our own AWS account, we can configure 2FA for our user and it will just work. And using this command and specifying this document, we will update the role policy. And now, so first, we are the hacker in this account, 259, then we will assume another role from the account 278. We will get the access credentials, and once we configure them, we will have the same level of access that that role grants. And this is, besides privilege escalation, this is a way to backdoor an AWS account and access it from an external account. Cool. Now, let's go a bit further and extend this idea of classic privilege escalation, because not every privesc vector requires only one permission to execute it. And we have to think about the sum of all the permissions that we have access to. And let's take, for example, this case where we compromise the user, and this user has the permissions to assume any role and pass any role to any resource. And next, we have another role that can be assumed by Alice. So basically, we don't have only our permissions from here, we also have access to these permissions, which in this case are Amazon EC2 full access. And there is a common vector in AWS where you can start an EC2 instance, pass it a role with high permissions, then connect to the instance and steal the credentials. And it would work like this. So we are Alice. First, we will assume the role, which will allow us to create an EC2 instance. And then Alice will come back to her permissions, will pass this role, which ideally would be a role with higher permissions. It will pass this role to the EC2, and then she can connect to the EC2 instance because when you are starting the EC2, you can specify or create an SSH key or using other permissions, and through the metadata API, you can exfiltrate the access credentials from that instance. But there is this question that, how can you find that role? Because when you are searching for roles, that role must have an assume role policy that can be assumed by the EC2 service. So you need to find that role. And there are a few resources. These are the tools that I personally would recommend. PMapper, I think, is the best for privilege escalation. It generates an HTML report with a diagram of who can assume what role, and it will display some privilege escalation vectors. However, actually this week I tested it on an environment with over 1,000 roles, and it just doesn't work because it takes a lot of time to compute all the connections between all the identities. But anyway, very good tool. Next, we have YAM Action Hunter, which I wrote an article about on securitycafe.ro if you want to know more about it. But basically, it allows you to find identities that can perform a certain action. So let's say you have half of the privilege escalation vector, and you want to know who can do a specific action. And with YAM Action Hunter, you can query who can do what. And it helps you in completing this kind of vectors. Next, we have Paco, which is I think is the most popular exploitation framework on AWS. And YAM Action Hunter is integrated in Pacu. I personally think Pacu is a little too much for privilege escalation, but it's a great tool to have. And lastly, we have Cloud Planning, which will tell you what permissions are dangerous on what identities, and it's useful if you are doing cloud configuration review and you want to identify weak spots. Now, maybe you are a hackerish person and you might get bored by this. And I can get why, because I also get bored. It's kind of easy. You just run CLI command, you gain admin, and that's it. That's not so fun doing that every day. And I want to show you some cool things in the hope that maybe you will consider doing hacking in cloud environment. So the first technique would be about SSM send command. So this is a built-in feature in AWS that allows you to execute commands on EC2 instances. The catch is that you can execute commands even if the instance is private and even if you don't have network connectivity to that instance. And even more, every command is executed as root or anti-authority system. And essentially, this sounds to me like the perfect command and control server, because it's also trusted by AWS. It executes the command as admin, and it doesn't require network connectivity to the instance. And let's take this example on how to exfiltrate access credentials from EC2 instances. So every EC2 instance has this local API called the metadata API that will store the access credentials for that instance. And if you make an HTTP request to this URL, you will get the name of the role that is attached to the instance. Now, once you have that role, that name of the role, you just attach the role at the end of the path. And when you perform this HTTP request, you will get the access credentials from the EC2 instance. And everything is happening through this intermediary. So basically, you are not directly communicating with the EC2 instance. And seeing this in action would look something like this. So basically, you can just copy paste this command. You just have to change the instance ID. This is the command that it's relevant because this will return the name of the role, which you need because you don't know yet. This will return a command ID, and with this command ID, you can get the output. So in this case, the name of the role is SSM full access role. And now we just attach this role here, and we do almost the same HTTP request. Again, we get a command ID. And with that command ID, we get the access credentials. And everything can happen from the internet without having public EC2 instances, the need of being able to communicate with the EC2 instance. So very powerful stuff. I've seen this misconfiguration multiple times because defenders are not fully aware of the dangers. So if you manage to get an identity with SSM send command and the permission to retrieve the output, then you basically have remote code execution on every EC2 instance in that AWS account. And I even wrote a tool for further exploiting this. It's called EC2 step shell that would, basically it looks like a reverse shell, but in the background, it just sends commands using SSM send command and retrieves the output. But it's a cool thing if you want to show the client that, hey, this essentially is a reverse shell, because kind of it is. And it will help you in explaining the risk to the client. Now, let's talk a bit about AKS, which is Elastic Kubernetes Service. So we can escape from AKS and gain a foothold in AWS through two methods, at least that's what I know. The first one is the metadata access. So it's a weird thing, but if you are in a pod So let's say this pod is exposing a web application. You compromise the web application, and you have remote code execution on the pod, or maybe just a server-side request forgery. So you can essentially exfiltrate the access credentials through the metadata API, just as we showed earlier, and the pod will have access to the same role as the worker node, which is not ideally, because in most cases the pod doesn't need the same permissions as the worker node, and even more, the worker node can be misconfigured and have a higher level of permissions than required. So this is one way to do it. Now, another way is to look for service accounts or pods that can assume web identities in AWS. And if you can't find, let's say you compromise the pod, and that pod doesn't have this configuration, there is kind of like a design flow in AKS that allows you to move from a compromised pod to any other service account in the same worker node. So basically you have a privilege escalation by design, and this works every time. Me and my colleagues, since we find this, we tested on every environment, and it works every time. And you can start looking for a service account that can move laterally to that pod that can assume the role from AWS. And I know this is a bit complicated, and it's hard to explain, but I'll try to do my best. First, I want to show you how that role in AWS looks like. So the trust relationship here, it's a bit weirder, but essentially what it matters is that we have this part that essentially says the namespace and the service account that can assume this role from that cluster. And we had a case where from AKS, we managed to assume a role in AWS that allowed us to further escalate privileges to another attack vector. And essentially, you want to look for environmental variables that contain AWS role RNA, AWS Web Identity Token file, and the token file is stored at this location by default. And once you have that token, you can run this command that will assume the role we just showed. And you just have to specify the web session token, which is a JWS token, if I'm not mistaken. So let's look again at the vector. Essentially, we are here. We compromise the pod, and we will get the credentials of the worker node through the metadata API, and then we will talk to the AKS control plane, and we'll act as the worker node. Then we'll say to the control plane, hey, I'm the worker node, and I need to impersonate another service account from my namespace. And we need to find a service account that has pod exec. So that service account needs to be able to execute code on that pod that is configured to assume the role from AWS. And if you didn't understand this, don't worry. It took me like, I don't know, a few days, a few tries to fully understand this, and it's still weird, but I definitely recommend you to look into it, especially if you are working with AKS, because this works absolutely every time. If the pod has access to the metadata API of the worker node, then this can happen. And we had another weird situation where pods were recreated in different worker nodes, and essentially from one service account, we just had to wait to the proper pod that had this assume role policy to be in our worker node. Okay, now moving forward, we can also steal credentials from Lambda functions, and with Lambda functions, the access credentials are stored in environmental variables, and here we have the access key, secret access key, and session token. And if you manage to read this file, proc self environ, you will be able to get the access credentials of the role. And this can happen in multiple ways. So either you can modify the code of the Lambda function and you can just read this, or maybe the Lambda function has a bad implementation. Let's say the Lambda function are doing HTTP requests, but they are not validating the schema, and you just specify this schema of file, and you manage to read the environmental variables, and then you will have the same permissions as the Lambda function. And also you can hack bad implementations. And here I'm talking especially about API gateways or Lambda functions, because from time to time you can find some weird API gateways that are taking the name of the resource, and with the permissions of the API gateway, they will give you that resource, even if you don't have that permission, right? But you can abuse this the permission of the service in order to do things in the name of the service. And I want to show you something cool about API gateways. So if you make a private API gateway, you can specify from what VPCs it can be invoked. And VPC are basically some private networks within AWS. And a lot of people are specifying an asterisk, so meaning that every VPC in AWS can invoke the API. And they think, the cloud engineers, they think that since the API is private, only the VPCs from their account will be able to invoke it. But that's not true. So from our own AWS account, we can create an EC2 instance in the same region as the API gateway. And if we configure a VPC endpoint, we will be able from our own AWS account to assume the endpoints from API gateway. And we had a case where this API gateway had endpoints to invoke Lambda functions with parameters and read and write files to S3 buckets. So essentially anyone on the internet, right? Because even if we are in a different AWS account, anyone can make one. So we can say that everyone on the internet was able to invoke Lambda functions and read and write files in these S3 buckets. It's true that you still need to know the API gateway address and its endpoint. So it's not like it's a high probability of this being exploited, but relying on security biosecurity is definitely not the right thing to do here. Something that it's not so cool and so hackerish, but I think it's still relevant, is attribute-based access privilege escalation. So in some AWS account, you may want to achieve this thing where the front-end team should access only these resources, the back-end team only these resources, and the database team only these resources. And you don't want to make a policy for everyone. You don't want to make a policy for each group. You just want to make a policy for everyone. And you can say something like this. So if the user has the team tag with the value front-end, he can access cloud resources with the tag name team and the value frontend. So basically, if you are a front-end developer, you will have a tag with this value, and you will be able to access only the resources with this tag, which in theory works fine. But the issue appears when backend developers, especially, they have permissions to modify Lambda functions, and Lambda functions ironically, in a well-implemented AWS account, they are doing automation and they have permission to modify tags. So this backend developer, he can modify the code from this Lambda function, or maybe he can just invoke it and change the tags. So it would work something like this. The backend developer will invoke or modify the Lambda function that has permission to modify tags. He will change its tag from backend to database, and now he will be able to access the database because that's how the environment is implemented. Essentially, doing a privilege escalation, which is not, it's kind of like a soft privilege escalation because you are just modifying tags, but you are still acquiring more permissions than you had before. Good. Let's talk about cross-account privilege escalation. So something that we see a lot is this kind of configuration. So we have a role in this account 278, and anyone from this account 944 can assume this role, which in theory is fine. Maybe you want to give access to multiple users to this role called auditor, but the issue appears when you have some identities, like an AI engineer from this account with 944, that can assume any role. So basically, this AI engineer will be able to assume this role, but he doesn't have any relationship to the group auditor. So he shouldn't be able to assume this role. And this is called the confused deputy problem, which is a weird name, and I had a lot of trouble with it. But if this AI engineer knows about this role called auditor, he can assume it. And this way, without wanting, you can give other people access in your AWS account. And let's assume that we got access to a management account from an AWS organization. It's not exactly like gaining access to a domain controller, but you can still do some chaos here. Maybe you can try creating new AWS accounts or modifying existing ones. Also, you might have permissions to change service control policies, which are some high-level policies that can prevent everyone from the AWS account to do certain operations. So you might allow your compromised user to do certain operations when everyone else will not be able to. Now, my take on privilege escalation is the next one. If you are doing a red team or an insider threat engagement, you should determine your permissions and build an attack path. But the most important thing is that you have to attack, right? You have to check and you have to validate, and basically what you manage to do, those are the results. So you start from one identity and you go towards the misconfiguration. You have to find it. But if you are doing cloud configuration reviews, you should find misconfigured resources and check for identities that can compromise that misconfiguration. So you start from the misconfiguration and you go towards the identity. I have a privilege escalation search order that works for me, and maybe it will work for you too. So the first step is to enumerate permissions if you can. But if you are in a red team engagement, you might not have the permissions to do so. So let's see the next step. You should check for one permission YAML privilege escalation vector. So you can either see your permission and determine if you can do that attack path, or you can try it blindly, because some of them will just work and you don't have to know what permissions you have. Of course, you have to be careful on what you are doing and what you are modifying. Next, you should look for roles that you can assume and repeat the step 2. So you identify a role that you can assume, and then you look for permissions that can lead to privilege escalation in one step. And next, you apply the sum of all permissions. So you check for previous vectors that require multiple permissions, and you combine the permissions from your identity with the roles that you can assume, or services that you might have access to. And next is exploitation of services, which involve services like EC2, Lambda function, AKS, API gateway, and so on. Well, some two more examples from our engagement. We had this role, which was something like multi-purpose role that has permission access policy. So this role had full administrator permissions in AWS, and the role can be passed or assumed by 7 services, some of them including well-known privilege escalation vectors. This was an issue because this gave us more chances to do privilege escalation, and we actually managed to find a user that had the permission to create a Lambda function and invoke it. So we create a Lambda function, we passed this role to the Lambda function, and we exfiltrated the credentials, essentially doing a privilege escalation to administrator access. Another example, we had this, so we compromised a user that was able to assume this role, but this role is configured to be assumed with an external ID. Essentially, it's like a password, but it's not considered sensitive. And if you know this external ID, you can assume the role. Of course, we were able to view this because we had read-only permissions globally, but we wanted to show the client that this is exploitable by an external attacker that doesn't have global read permissions. And we found this role that had a name like test and developer name, which was the name of a developer. And the role was assumable by any principal. So this asterisk means that anyone from any AWS account can assume the role. And ironically, the role had permissions to view this external ID. So basically, from our compromised user, we assumed this role. We checked the external ID from here, and then we were able to assume this management role that had administrator permissions. Good. There are a few more slides. Please bear with me. I know this was a lot. I also have a cool demo in a moment. But until then, I have another example. So you can take a look on hacking the automation logic inside that environment. I saw one environment that had a Lambda function that was taking certain events that were generated automatically. And in the functions code, there was a vulnerability that allowed you to exfiltrate access credentials by reading the proc self-environ file. So you can take a look at this, and maybe you can trigger some events that will give you this, that will compromise the code from the Lambda functions. Now, you might want to do some enumeration on your permissions, but you don't have the permission to actually see the permissions. So you have to find them in another way. And there are some cool tools. This one, enumerate yum. This checks every read permission in the AWS account. So it will tell you what read permissions you have, which is fine. But if you want to do privilege escalation, you also need to know what write permissions you have. But this tool doesn't do that, because it plays safe, right? There's another tool called CloudTrail to YAM. So basically, this tool will check the logs from the AWS account and will see what your user did. And this way, you can find additional permissions, write permissions, that your user did in the past. And because the permissions, the actions that your user did are in CloudTrail, you can say that your user has that permission. There's Paco, which can also enumerate permissions, but it can also automatically try to exploit certain privilege escalation vectors without knowing if you have that permission, and which is another way to validate if you have that permission or not. And of course, we have AWS CLI, which in the end is an amazing tool, and it helps you, especially in the beginning, to better understand what some services and some permissions are doing and how they can be abused to escalate privileges in the end. Okay, I have some tips for you. If you are if you are doing enumeration in the dark, you might be in a red team engagement, and don't use well-known hacking operating systems like Kali Linux, because this will generate alerts in a service in AWS. you should keep generating new sessions. So there is this weird thing in AWS. Let's say you have access to one set of access keys, and you are generating a new session with this command that will be available for 36 hours. If the defenders find you and delete the access keys, with this session, you still have access to the environment, even if the keys are deleted. The right way to cut access is to put a deny statement on that user for 36 hours in order to prevent them from using this technique with get session token. And before you ask me, no, you can't generate new session tokens using a session. And there is this cool research done by Nick Fritchett, I hope I pronounced that right, which involved evading logging by using staging and secondary APIs from AWS that were somehow connected to the production data. So basically, you query with your identity a staging AWS API, and you can verify if you have permissions to do something without being logged in CloudTrail. Cool. One thing that I don't like when talking about AWS exploitation is that I'm not giving any way of gaining initial access. And I want to tell you about shortly about a research I've done recently that actually gave me and my colleague Matej Josefs, which presents right next door, access to over 120 AWS accounts with 20 access credentials from root accounts. So basically, we search for in public AMIs. An AMI is like an image for a virtual machine, and every EC2 instance is started from an AMI. So we scanned over 27,000 AMIs that were public, and we find a lot of secrets, but most importantly, we found 120 unique access keys that were valid. So basically, we had our initial access that we could have used to further try to do privilege escalation. So there are still ways to get initial access, even from the internet, even if you don't have any knowledge or insight in that in the target's AWS environment. Now, demo. Last week, I identified something cool. So again, I don't like this idea of not giving you an initial access possibility. And what I will show you next is basically a way to start from anonymous permission. So basically, you are no one in that AWS account, and you can gain administrator access by assuming a certain role from some AWS account. So we will create a web identity for Terraform, which is a common thing that people are doing. And when we are creating, we will give the administrator access permissions because Terraform should be able to do everything that it's supposed to do. And as you can see, this will have a OpenID Connect trust policy, but most importantly, by default, AWS doesn't give you the possibility to specify what organization from Terraform is able to assume this role. And this might allow cloud engineers to do this mistake of leaving this role as it is. Now, so we are done with that environment. We are now in Terraform Cloud, and we will specify as environmental variables two things. First, that we want Terraform to authenticate with AWS credentials, and then we will specify the role that we want Terraform to assume. it's true that you still have to know the name of the role and the account ID in order to assume it. But if you know your target and you can find the account ID, you might be able to guess the name of the role because it's something like Terraform Open Connect. So here we will create a new role that will be assumed by, which will be backdoored by our AWS account. And obviously, we are attaching the administrator access policy to this role. Now, when we apply Terraform, in the background, Terraform will communicate to Terraform Cloud. It will assume that role, and it will generate the state, and it will say what it will be modified in that environment. And in this case, so it will be attached the administrator access policy to our role. And next, we will create this role that will be assumable from our own AWS account. Cool. The resources were added. Now we are in this profile hacker, so we are in this AWS account 944, and we will assume the role from 278 that has this name that is hard to spot, right? AWS services role for automation. Maybe someone will not detect it. This will give us the access credentials. And once we configure the access credentials, so we need to access the access key ID, secret access key, and the session token, we will have the same level of access as that role. So let's call again the identity of the hacker, just to see that there are different access AWS accounts. So this is 944. And now we will check the profile of the backdoored role. And we will see that the AWS account is different, is 278. So from having 0 access in one AWS account, if we are a bit lucky, we can gain administrator access in another AWS account, and this is something that I discovered last week. I initially wanted to do a different demo, but this came up, and it seemed like a better idea. Also, what I showed you, this is my next idea research. I want to collect as many AWS account IDs as possible, and I want to try to find roles with different names like Terraform, OI, Open Connect ID, and stuff like that, and see if I can identify other roles with administrator access in other AWS accounts. Now, let's talk a bit about mitigations. So the most important thing is least privilege principle. I can't stress this enough. Even if you have a Lambda function that has permission to create access keys because you have automation that will change the user's credentials, at least don't allow anyone else besides some people modifying that Lambda function. So they shouldn't be able, not everyone should be able to access the Lambda function. So it's fine if you have some privilege escalation vectors in some resources, if you know about them, but at least restrict the access to the services so that no one that shouldn't access that resource will do it. Next, we have service control policies and duty segregation. So you can specify at the organization level what can be done by who, and this will limit the things user accounts and roles can perform in your infrastructure. And duty segregation, so you should not give an administrator access to everyone. You should have specific roles and permissions for developers, DevOps, and so on. You should implement a good architecture, so separate AWS accounts per environment and solutions. If you have a single AWS account where you have all your application and dev and stage and prod, it will be a nightmare for us for checking the security of that environment. But it will also be disastrous if someone compromises that account because everything will be affected. You should do periodic review of the permissions you have in your AWS account, and cloud configuration review for ensuring that some things are checked from a security and offensive perspective in your infrastructure. Now, final thoughts, and this is my last slide. For defenders, you should regularly review the YAM resources, implement automation for incidents that will invalidate access and limit the access and permissions that someone might have. And for hackers, complex environment means privilege escalation most of the time. Configuration review, you should perform it with or without execution. It doesn't matter, it's important to identify the issues. And if you are doing red team, you should have execution and also stealth. And a bit of advice, you should hack the cloud while it's still easy, because it still is, and defenders are not yet prepared as we hackers are. Thank you. Any questions? And also, I was asked to remind you to give feedback before you exit using the postcards. Thank you. Hello.
Is it on? Yes. Hi. Congrats for this research. I know it's a lot of work, logging everything and just gathering all this information together, especially from AWS.
Yeah.
My question is, when you were talking about escaping from the Kubernetes clusters, from the pods, does CloudTrail log the action of escaping, or does it log the actions that you do outside of the pod and directly on the worker node?
It should. I didn't verify it, but it should, because you also have or should have logging at the cluster level. But whenever you are assuming identities in AWS, CloudTrail will log that activity. So you can find that out, but it's a lot of noise in the AKS cluster, and maybe the AKS, the control plane, will also assume the role of the worker node, or will do some operations around that, and it will be hard to find out, but I honestly don't know, but it's a good question.
Okay, thank you.
Well, if anyone has other questions, or yes, please.
Would guard duty find what you did in the demo?
No. The only thing guard duty will tell you is if someone performed API calls from Kali Linux. So that's it. Even if you are running well-known payloads using SSM send command, so payloads for reverse shells, guard duty will not tell you anything. And I know it's a bit weird, and you might get some alerts if you are doing a certain enumeration with certain API calls, but in my experience, the only alert from guard duty is that we are using Kali Linux, and I usually laugh because the clients are all scared. Hey, is this you? Only one alert from Kali Linux when we are doing privilege escalation in their environment, and they are worried about an alert with Kali Linux. So, yeah, that will be all from guard duty.
Thank you.
You're welcome. Well, thanks again, and if you want to talk more about cloud security, you can find me around here today and tomorrow, and you can also hit me on LinkedIn or Twitter or wherever. Thanks again for joining.